Right, so we're going to ask about we're going to ask about some talk about some programming paradigms. Right, and we have some different ones to talk about. What is a programming paradigm? Right. Well, we have different types of problems. Right. We have different types of problems, and that would require a different approach in terms of being able to solve a problem. So when we have, programming has developed in different ways to allow for programmers to be able to solve these problems by creating different programming paradigms. So a programming paradigm is really and truly like an approach to programming. Okay? Is an approach to programming. So you could say that it's the method that you use to solve the program or the task. All right. It's in terms of like how you would have to think through a particular solution, right? What approach are you taking to solve this problem? So from the perspective of a paradigm, that's where that's where you approach. Like some programs are very simple because sorry, let me say sorry. Some problems are very simple. And as a result, you're not going to take an overly complicated approach to solving that problem. Okay? We haven't learned C here, right? We haven't learned C here. We are under the procedural slash imperative paradigm. What does that mean? Well, as I told you all before, procedural and imperative are two different things, but they're very similar. We take a step by step. If you look at the imperative paradigm, it's one of the oldest programming paradigms, and what it is that it just basically takes you through that input processing output. Your procedural or imperative paradigm takes you through that whole input. And this follows, most other paradigms follow this, right? But processing, output, cycle. And you have your loops, you have your variables. It works by having like a step-by-step task towards changing the state of the programs. Okay, so you have several statements, and once you go step by step following each statement, by the last statement, your program or your problem should be solved. Okay, it's not too good for solving extremely complex problems. It's not too good for solving extremely complex problems, but it is a nice place to start. That's the imperative. The procedural takes the concept of the imperative, and it allows you to break that program up into functions. So whereas the imperative was just this long list of the imperative was this long list of items that you could have done and said, okay, you must follow this. You could have loops inside of here, right? You could have decisions and do one thing or the other. Okay. So you could go one route or the other and then follow some more statements, and then boom, you finished at the end. What your procedural allowed you to do is that your procedural allowed you to break your program up into manageable parts. So we could take out parts of the program and call them as like functions or methods or procedures. right? It allowed us to pull information out in terms of being able to reuse code, right? So it also allowed for the imperative. It's an evolution of the imperative paradigm, essentially. Are you all with me? Everybody understand that? We have been coding procedurally, right? We use functions. We do step by step. We do step by step instructions. We have been coding functionally, and we have not really seen in our class implemented any of these other paradigms, because outside of knowing about the other paradigms conceptually, we don't really have to do it, right? When you all go to university, chances are you will meet object-oriented programming. You will probably have to write a couple scripts here or there, right? If you go into computer engineering, or in engineering, you might meet some functional programming. I have never really had to do any functional programming, right? But you will meet declarative programming. Some of you, if you are doing IT, next year, when you start to learn HTML and web-based programming, you will meet declarative programming. Okay, so I'm just going to explain the concept of the object-oriented paradigm to you now. So if we have the object-oriented paradigm, the object-oriented paradigm, right? The object-oriented paradigm considers everything in your that you want to represent virtually as an object. And what is an object? An object is something that has behaviors, and an object is something that has attributes. So if it is that I am programming, if it is that I am programming a school information system, an object within the school information system might be a student. And what information do we want to keep on students? That's their attributes. Okay? A student would have attributes. What's an attribute of a student? Something like the date of birth, the name. Okay? What else is an attribute of a student? Right? The date of birth, the name, the address. Okay? What's a behavior of a student? A behavior allows for this object to do a task. So in terms of programming, where we have, and this is why it's a paradigm, because it's a shift in thinking. If you were writing a student information system, you would have a function called register that would register a student. But a behavior is how an object can interact with another object in object-oriented programming. So we can probably have another object called a subject, right? A subject. And what happens with this subject? The subject would have its attributes. So a subject would have a name. A subject would have a description, right? And a behavior, it really dictates how this object could interact with another object. Okay, so this student object would have a behavior called register. And this register behavior would allow me to register for a particular subject, right? So I could register for a subject. So my student object could register to do a subject. My student object could do something like withdraw. So what is an object-oriented approach? An object-oriented approach allows us to program in such a way that we are trying to mimic real-world entities. And it allows us to be able to give those entities attributes and behaviors so that those objects can interact with each other. Okay? So it's very data focused, and there are some advantages that come with object-oriented programming. Right? We have some advantages that come with object-oriented programming, like something called inheritance. Right? If we think about creating an object, let's say, for instance, we wanted to create a biology program. Okay, you wanted to create a biology program, and you want to create an animal. Could anybody tell me what an animal, just general animals, right? So this is my first object, animal. Give me a feature of an animal. Right? So an animal is a class of things. What is different between animals and plants, probably? Anybody? Anybody here could tell me what's the difference?
It's
Huh?
someone can create their own food.
What was that? All right, I got a real biology answer there. Can you repeat that, Chelsea?
Plants can create their own food. Some plants.
Right. So some plants can create their own food. Animals. All right, you all hearing me again?
Yes, sir.
Yeah, somebody called my phone, so I got bumped off. All right. So, are we still recording? Hold on, let me just confirm. We should be. Yes. All right. So, right. So we say in terms of classes, all animals eat. Okay. So, but then we have so that's a behavior common to all animals. We have classes of animals. What kind of what classes of animals we have? Come on, people. What classes of
Mammals.
animals? Right. So we have mammals. We have birds. And what else do we have?
Reptiles.
Amphibians.
Reptiles. I'll take reptiles. And each of these now, and this is something that you actually get from the object-oriented paradigm, is that all three of these classes here are going to be able to inherit the ability to eat. Do mammals eat? Yes. Do birds eat? Yes. Do reptiles eat? Yes. Right? Let's say, for instance, all animals have skin as an attribute. But mammals and birds and reptiles have different type of skin. So this is something that is also useful to know about object-oriented paradigm, right? That your animals have skin, but mammals have fur or hair. Birds have feathers, and reptiles have what? Scales? Scales or creepy skin? I don't know, right? So all these animals inherit skin and the ability to eat from their superclass. But then when I implement a subclass of mammals called a subclass of animals called mammals, I overwrite that skin, or I enhance that skin for mammals by giving them fur or hair. I enhance that skin for birds by giving them feathers as an attribute. I enhance that skin or that whatever skin for reptiles by giving them scales. All right? And again, I can make subclasses. Look, what is the difference between a dog as a mammal and a human as a mammal? Right? We could have the ability to talk or to make sound as a behavior. Or even let's say make sound is a behavior from animals in general. Right? Make sound is a behavior from animals in general. And I have a dog and I have a human. When I have that make sound for dog, I could now overwrite the ability to make the sound by giving dogs the ability to bark and giving humans the ability to talk. So if it is that I am making a video game and I have to make creatures in a video game, what I could do is I could make a superclass with features that are common to everybody. And as I start to make subclasses, I pick which features I want to keep from above or which features I want to make new. So if I have a mammal in my video game and I have a human and his dog, the human has the ability to talk, the dog has the ability to bark, right? I could also change attributes because for humans, I could say hands 2, legs 2. I could say for the dog, legs 4, hands 0. You understand where I'm coming from with this? So this allows us to start to customize entities by messing with their attributes and messing with their values. You all understand the paradigm? How it works?
A bit better, yeah.
Right? So that is one of the key features of the object-oriented paradigm. It allows for classes to be made for objects, and it allows for subclasses to be made that can enhance objects further or modify objects further. Okay? And the last, not the last one, sorry. All right, so erase, oops. If it is that I am going to so we spoke about object oriented, we spoke about procedural. Let's talk about declarative. And the rest of these, you just basically kind of just need to know the definitions of them, right? Declarative programming is declarative programming is more concerned about what is being done as opposed to how it's being done. Okay, and functional programming is a subset of declarative programming. Okay, we are very concerned with, in terms of functional programming, with the idea of how mathematical functions work, right? In terms of a math function, we are told what to do, we're not told how to do it. But when you feed information into a mathematical function, right, you could see the results on a graph. Okay, so it's very similar to that, right? And that's declarative and functional programming in general. So declarative as a paradigm is really just concerned about the underlying aspects of what is happening, right? So you might be able to, like say for a declarative paradigm, you could use the SQL code or HTML code as saying, I am telling you to create a web page. Anybody here ever made a web page before or played with HTML code before? Yes, no, right. So Jaden, okay, Jaden knows what we're talking about.
Yes, sir.
All right. So in HTML, if I want to create a table like this on my web page, right? Let's say I want to create a table like this on my web page. I am just going to write some code that says, okay, that says table, right? And I have, forgive me, my HTML is a little rusty. I have 4 rows and 2 columns, right? So I will say table row, right? Table TD is table data, right? 1 TD and table data 2 TD, right? And then I say stop this table row, and I can continue on with that, right? Dot, dot, dot. And then when I want to stop the table, I say table. So I am declaring how a table is supposed to be made. And so I have 1 and I have 2 inside here. That's where this 1 and 2 come from, right? And I have my other information that would be very similar to this. I have declared how that I want a table. How is this table going to be made? There's something else that is processing this information, that's dealing with this information. Okay? I'm not really saying, okay, draw the line and the table is supposed to be this size and the color of the table is supposed to be. I could define those things later on. But even when I define those things, I'm not telling the computer how to make it. I'm just telling the computer that I want it. Okay? All right. And the last thing that we want to talk about in terms of these is the scripting aspect, right? The scripting paradigm. And a script is essentially something that, or it's essentially a program that adds functionality to another program. So your script would be something that exists within a bigger system. Say, for instance, and this is why, like, you could call some languages scripting languages, because what it does is that it adds functionality. If you have a web page and you want some further functionality to the web page, you could, on the client side, add a JavaScript. And that will make that web page a little bit dynamic. Or you could add PHP to it, and it will make that web page, server-side dynamic. We could do calculations on the server side and print out something on the computer side. If you have an operating system and you want that operating system exists as itself, right, as a complete and full system, but you need something to be done to enhance the ability of that system, then you could use a script to do that, right? So it's not too much like a full paradigm, but it's a feature that is so useful and so ingrained that you could think of it as you could think of it as something that enhances a particular paradigm, because scripting is not like a whole language by itself, but scripting is supported by a lot of languages, and scripts do particular tasks. Okay, so it is just the ability to be able to add functionality. So if it is that I want to write a script for my system, let's say, for instance, I have some issues with, when my computer starts up, I want for a specific program to be run, or for some specific data to be collected. I could now write a script and add it to the startup of my program, so that now my operating system has this additional functionality that is achieved through the script that I have written. You all follow me?
Yes, sir.
Okay. All right. Right. And so the last thing that we want to talk about today is, all right, so Joshua says not really, on what, the scripting?
Yes, sir.